Going to the moon is not something that happens every day. In fact, for more than half a century, no human spacecraft has traveled beyond low Earth orbit. This long silence connects two missions, Apollo 8 and Artemis II. At first, they look similar, both send humans around the moon, and both test a spacecraft designed for deeper space. But beneath that similarity lies a difference. Apollo 8 was never part of the original plan. In 1968, NASA had to make a critical decision. The lunar module was behind schedule, and intelligence suggested the Soviet Union might attempt a crewed mission to the moon at any given time. Waiting was no longer an option. NASA made a radical decision. They removed the lunar module entirely and sent the astronauts to the moon using only the command and service module. The mission was prepared in just a few months. Apollo 8 was literally a sprint, driven by urgency and uncertainty. Artemis II exists in a very different context. It is not a reaction, but a foundation. The mission's design is part of a long-term architecture, meant to support repeated lunar flights, landings, and eventually missions beyond the moon. The record for the furthest humans have ever traveled from Earth was set during Apollo 13, a journey driven by urgent circumstances. The crew was put on a free return trajectory, which uses the moon's gravity to safely bring the spacecraft back to Earth even if the engines fail. Apollo 8, by contrast, stayed closer to the lunar surface, essentially simulating the operations that would have involved the lunar module had it been ready. Artemis II takes a bolder route, following a high-energy free return trajectory conceptually closer to Apollo 13. Instead of braking to stay at the moon, Orion, the modern equivalent of the Apollo command module, uses lunar gravity as a gravitational U-turn. This slingshot effect propels the spacecraft thousands of miles further into the void than Apollo ever went, before Earth's gravity eventually brings it back home. Hundreds of thousands of simulations predict and validate every maneuver even before the astronauts leave the launch pad, ensuring the crew can safely return to Earth even without using the engines. Apollo 8's crew of 3 was selected for endurance, and Apollo crews in general consisted of military test pilots trained to operate under extreme stress and little margin for rest. Life inside the command module reflected that philosophy. There was no toilet, limited space, and no real way to divide the workload evenly. Orion shows a different approach. The spacecraft itself is designed for longer missions with 4 crew members, allowing missions to operate in shifts, and their diverse background reflects the philosophy of the ISS. It creates a small social ecosystem designed to thrive even in the extreme environment of deep space. Once Apollo left Earth orbit, navigation became a human responsibility. Inside the capsule, astronauts used a manual sextant, a tool borrowed from centuries of maritime navigation. The computers were revolutionary for the late 60s, but they still depended on human input to stay accurate. Any small discrepancy could have translated into hundreds of miles of error upon return. Orion solves the same problem differently. Instead of relying on the human eye, it uses optical navigation. Cameras track stars, Earth and lunar features, while the computer compares them against an onboard database to calculate the spacecraft's position automatically and continuously. The Apollo 8's Christmas Eve broadcast remains one of the most iconic moments in spaceflight. The crew didn't talk about technology. Instead, they read from the opening lines of Genesis, a creation story shared by billions of people on Earth. It was a moment of humanity spoken from the moon. But behind that historic transmission, there was a severe limitation. The data moved slowly. Voice, telemetry, and video shared an extremely narrow radio bandwidth. Artemis II, instead of relying solely on radio waves, the mission incorporates optical laser communications, using tightly focused beams of infrared light to transmit information. This approach allows far greater data rates. The moon is no longer just a distant voice on the radio, and it becomes a place we can observe in detail in near real time. Apollo 8 proved that humans could reach the moon. Artemis 2 proves that we can return with intention. Both aim for the moon, but with different goals and methods. Together, they reflect what we've learned along the way about spaceflight.